This is Remote Lab A 556 timer. As you can see, the duty cycle generated by the timer is recorded in terms of the time on and time off, both in microseconds. There's also the calculated total time in microseconds, as well as the calculated frequency in hertz. These are all shown in the serial monitor. You can see when it's all the way to one side, we get a frequency of 1.17 hertz. You can also see that if we put it all the way on the other side, the timer entirely stops, giving us a frequency of infinite hertz, but that's meaningless. Now, if we nudge it just a bit so that there isn't zero resistance, we get a frequency about 1.79 hertz. Now, if you see the red LED on the bottom coming from the Arduino itself, that is the mimic function being called. So you can see it runs in 5-second increments, and it still stays at 5 seconds even if we decrease the frequency. Now, I'll show the operation on different potentiometer values. Now, sometimes the two LEDs will be out of sync, and this is because the frequency recorder or the frequency calculations are assuming that it's all on the same resistance or all on the same. It assumes that the duty cycle doesn't change, essentially. However, when we do change the duty cycle, that's when errors occur. However, if you leave the potentiometer untouched for long enough, you get the mimic correct. You get the mimic working correctly. This was Remote Lab A 556 timer.